My name is Johnny Klusinek, and this is my final presentation on my OpenGL and OpenCL particle system. So the goal of this particle system was to rewrite the old one that was written by Professor Mike Bailey. I just wanted to make sure it worked cross-platform on macOS, Windows, and Linux without the students having to configure anything special. So if we get into the exact things I changed, the first thing I had to do was I had to completely rewrite the OpenGL side of things. So I went from using Glut, Glue, and GLUI for a window manager and UI stuff to using GLFW, GLAD, and ImGUI. I also had to force OpenGL 4.1 core because the old project used compatibility, but the only one that works in macOS is core, and 4.1 is the latest version that works in macOS. I also made the code a little bit easier to understand from organization as well as code structure. So everything is still in one file, but I did add some helper functions in separate files to make the code a little bit cleaner. I also used CMake to make everything cross-compatible. And a big thing I did was I improved the benchmark GUI stuff. So basically, I just added peak and average particles per second instead of just the instant ones, which I'll show you in a second. I also added an overlay versus a separate window. And I used Chrono Steady Clock instead of OpenMP because C++ now has basically the same type of timer that OpenMP had for tracking stuff. So we go into the old code. Again, it still looks pretty organized. It's just, as you can see, at the top, there's a lot of global variables and stuff like that instead of just, I'll show you what I did in a second. And the code itself is still clean. It's just some things could be a little bit more up to date and modern. So if we go to my code, again, it's very similar at the start, but then the config options are the same. But then if you go to the actual global variables that you might have to change, these are all separated into structs. So the students know what goes with what. It just makes everything a little bit clearer. And the code itself is still pretty similar. I just made sure the comments were a little bit more organized, as well as I had to, again, the OpenGL stuff is completely different, so that's a big difference. But again, if you want to see the actual differences, you can just compare the code side by side if you want. And then if you actually go to running the code, as you can see, the old one opened two different windows. So there's a separate settings window over here as well as the program itself. And if you show the performance, it only shows the current one. So it doesn't actually, you can't really see what's happening because you have to pause it and play and pause. You don't really get an accurate measurement. And then if we go to my code, so if I go back to the top here, you can just run it with a simple command. And you click show performance. Now mine shows the current, peak, and average. And my particles move slower because I just changed it to be that way. But you can also see that my score is quite a bit higher, which I'll explain in a second why. But the hint is it uses steps per frame now. But yeah, basically, it just makes it a little bit easier. So the reset and everything, it works fine. It just shows that the students can actually pick the average instead of having to pick a random number and pausing it and playing it and pausing it just to get an accurate measurement or whatever. This program just does it all for them now. And then now to see why I get better performance is I also completely updated how the OpenCL code works with the OpenGL code. So again, it's cross-platform. I moved some the print stuff and error functionality to a different helper file. I did modify the kernel code to force a correct workgroup size. So in the old code, if you didn't select a proper local size or whatever, it would still just give you about the same performance. But I actually added right here a barrier to force it so this kind of syncs up. It makes it so the code actually gives you better performance when you select a proper local size versus if you set this to 1, it wouldn't really make a difference. Now it actually does make a difference to what you changes to. And then I also, instead of shipping the code with lib files that only work with the Microsoft compiler, I use CMake to make sure I get the proper files from GitHub and whatnot. So if you're on macOS, Linux, Windows, or if you're using the Microsoft compiler, GCC, CLang, it all works now just without you having to configure really anything. That really does help a lot with the simplicity of stuff because again, it's the same commands, whatever, for macOS and Windows. And the reason that my code actually seems to work a little bit better is because I had this thing called steps per frame, which basically, so the way the old program worked is every single time, this would happen every frame. OpenCL would acquire the buffer, do some calculations, give the buffer back. But it would do this every single frame. The way mine works now, it's very similar. However, I think there's a thing called steps per frame here. So every frame, it acquires the buffer, does the calculations as many times as you want it to, and then goes next and keeps going and going. So basically, I have to do the calculations multiple times per frame instead of just once. And that's one thing that students actually get to pick whatever value they want, test it out, and see which one works best for their system or whatnot. And the other big thing I changed was so I completely rewrote the README and stuff like that to use Sensical instead of just basic, I think, HTML. So this is what the old site looked like. It explains stuff pretty well. It's just some things it can be overwhelming if you're just reading all of this at once. Because again, it's a lot of code, a lot of words. Sometimes for some people, this could be harder to find stuff or a little bit hard to understand. If you go back to mine, I completely rewrote everything. So mine actually contains a lot more information, but it's written in a way where it should be easier to digest. So it kind of gives it an overall goal of what you're doing, project layout, the platform setup. Since again, you only have to do one platform at a time, you don't have to do all three. I separate them so you can see like for Windows, if you're doing Windows, you don't have to like check the macOS stuff out. You can just leave the Windows one open. And I give instructions on how to do it for like Ninja and CLang or GCC and Ninja or the Microsoft one, like whatever the students have installed. Again, you have like clickable instructions, so you can actually see like you just click on these. One thing I did was for like the results, I added an example graph, which isn't shown in the other one, but I also made it so if they want to get this exact same type of graph, I actually gave them a website and the exact code to just like fill in their own data once they get it and test it and everything, so they don't have to make the graph themselves in Excel or whatever. Also for the bottom, I made it so you can actually, so I think before over here it shows like all like the examples, like what the sample code does, like how to advance a particle, like what the kernel does basically. But like you don't really have to know about that stuff until like it's kind of good to like realize what you want to do and then kind of understand like if they want to like, okay, this is what the kernel does, this is what the sample code does. So this is all at the bottom where it's all separated and pretty easy to understand. I like blocked it off pretty well. Made sure like there was code blocks for everything so they can copy and paste this code if they want, but also just visually looks a little bit easier to understand. And again, this light and dark mode, which is nice. You can even search if you need to, which is cool. And the big thing about all of this is I made it so it automatically rebuilds when you push it to GitHub. So like let's say I change some of the source code or some of the tutorial stuff, it will automatically rebuild and redeploy onto this website. But I don't have to do any of that manually, which is cool. But even let's say I change the code, I can just change the tag or add a new tag, push to that tag. And then it automatically gives you the latest release. So you can give the students like a direct link to this every time. Or it just downloads the source code, but only the stuff they need to edit. Because they don't need to worry about like the Zensical, like front end stuff. They just have to worry about the actual code that they have to touch and everything. So that gives you it all in one nice little zip file. And then, yeah, so I talked about the OpenGL interop stuff and then the general code refactoring. And again, just to look at the actual code refactoring again. As you can see, if I just close all this stuff. Basically, the old one worked this way where everything was just in one file. You had to use Visual Studio Code. And again, it worked. It just could be confusing for people. You know, a lot of lib files that only work on Visual Studio. So again, I made it so you don't have to get all this stuff. And now it kind of gets all like dynamically. It's built a little bit different, organized a lot better. Again, all the frameworks are organized by like what you get them from, like GLM or whatever. My utils and like fragment files are right here for like the shaders. And all the main files are just right here. So again, it's very organized, very easy to understand. And it should be a pretty straightforward project for students to get going and up and running. And again, the instructions themselves kind of go over like what everything does. So hopefully for students, but also for anyone just like looking into this, just should make a lot of sense, but also be like a very helpful project for them to do and implement.